This video on sign convention in spherical mirrors is for class 9 ICC students. There are many students who find the sign conventions of the positive distances or the negative distances or the heights confusing. In this video, I shall explain to you these difficult concepts and show you how to write the answers to get full marks, so that the examiner is forced to give you full marks. Let us begin to understand the sign convention in spherical mirrors then. Now here you will see this is the concave mirror and this is its principal focus and this is the center of curvature. The distance between P and F and C should be equal whenever you draw the diagram. Now remember, the object is always going to be in front of the mirror. The incident ray will come from the object like so, correct? Now the ray that is coming from the object, it is called as the incident ray, and the direction of the incident ray is considered as positive. So in this direction, you will be looking at these distances on the right hand side, they will be positive. So our rule number 1 is that the direction of the incident ray is positive. The second rule now is all the distances are measured from P, which is the pole, that is this point over here. So the distance of the object will be taken from P up to this. So we are going to go in this direction. Is it in the same direction of the incident ray? No, it's opposite. So this side, when we are looking at the distance, it is going to be negative. Alright, if we are measuring from P distance this side, it will be positive because it is in the direction of the incident ray. And if we are measuring from P this distance, then here the distance we are going in the opposite direction, so that is negative. Also, rule number 3, heights above the principal axis this way, like we have the object here, this is going to be positive. But if the height is below the principal axis this way, then that is going to be considered as negative. Okay, now let us see a simple short trick to remember this. If we consider this as the y-axis, the vertical axis, and if we consider this as the x-axis, then this becomes the origin. Now in the coordinate system, remember that there are two number lines, both intersecting at 0. This side will be positive 1, 2, 3, 4, 5. So this side is going to be positive and this side will be negative 1 and negative 2, negative 3. So this will be negative. If we go up the y-axis, remember it is 1, 2, 3, 4, 5. So that is going to be positive. And if we go below this way, then it's going to be negative. So we consider exactly the same thing. If you keep the mirror in such a way that the pole coincides with the origin, then on this side, if we are going from the pole, we have to measure the distances. These distances will be positive. And from the pole, if you go to the left, it is going to be negative distance. From here, the principal axis, you go above, it's going to be positive height, and if you go below, it is negative height. It is just like your coordinate system. Okay, so if we keep that in mind, then we are going to have very easy time. Now if I have the object, remember object is always in front of the mirror because this is the coated surface and this is the shiny surface. In the shiny surfaces, we will see the reflection of the object. So the object, it is going to be from P up to here. We have taken the distance from P on the left. So this becomes our negative distance. So remember, your object distance is always negative because the object is always kept in front of the mirror. So whenever in the question you see in front of the mirror, remember it is negative distance. Now if the image is formed in front of the mirror, then the image distance will be measured from here up to here, and you are going to go this way, which is opposite to this direction, and so the image distance will be negative. Okay, if the image is formed this side over here, then the image distance will be from here up to there, and that is going to be positive distance, measuring from here. From the pole we have to measure. If we have inverted image, you are looking below the principal axis, so that height will be negative. If we are looking at the object is always upright, remember that. So when it is upright, we are looking at something which is above the principal axis, and that is going to be our positive height. Okay, now that we understood this, let us look at the focal length of the concave mirror. Now if I have the ray coming parallel to the principal axis, what does our rule say? The rule says that this ray gets reflected and it passes through the principal focus, correct? And also if we take another ray like so, then this also after reflection is going to pass through the principal focus. And so you will see that the rays which are parallel to the principal axis, they are converging. Now from here to here, what is this? This is the focal length. So we measure from P this side, so we are going to negative side. So the focal length of the concave mirror is this way, means negative. Okay, now let us look at the convex mirror. For convex mirror, we make sure that this line over here, the origin coincides with P, that is the pole of the convex mirror. Now the rays coming parallel to the principal axis, they are going to get diverged, and these rays will appear to be coming from this point on the principal axis. Now this point over here is the principal focus of the convex mirror. So here you will see that the distance from here to here is the focal length, and we are measuring from P on the right. So on the right means your focal length is going to be positive. For which mirror? The convex mirror. Okay, so now that we understood this, let us take one simple question. Find the position of the image when an object is kept at 10 centimeter distance in front of a concave mirror of focal length 20 centimeter. Now because it is concave mirror, remember its focal length, which is 20 centimeters, it is going to be negative. Now if you are confused about this, just quickly draw a diagram like this. Okay, show this ray going this way. Now can you see? This is the focal length. Now if you consider this as point P, on the right if you go, it's going to be positive, on the left it's going to be negative. So the focal length is going to be 20 centimeter with negative sign. Object is kept in front. So object distance will be in front, means it's going to be this side. This is where the object will be. So the object is in front. So if you are measuring the object distance, you go from pole this side, means on the negative side. So minus 10 centimeter. And then we have to find the position of the image, means the image distance, and we write the formula as 1 upon f is equal to 1 upon u plus 1 upon V, and therefore we will have 1 upon V equal to, this goes that side, so 1 upon F minus 1 upon V. Okay, now 1 upon F, what is the value of F? Minus 20, minus 1 upon U, how much is it? So we will get LCM as 20. So here it will be 20 ones 20, so minus 1. This will become positive. Let me just write it this way, so it's easier for you. And 10 goes twice, so plus 10 to is 20, so 2 here. That will give us 1 upon 20 with the positive sign, correct? So therefore V will be equal to plus 20. Now what does plus 20 centimeter mean? That the image is on the right hand side and it is plus 20, means it's going to be like so. So you will see that the focal length was 20 centimeters and the object was kept within focal length, and that's why we got the magnified virtual image. The virtual image is on the right hand side, it is behind the mirror. This part is in front of the mirror and this part is called the part which is behind the mirror. Okay, so we'll say therefore image is formed 20 centimeter behind the mirror. Now from this you can even write the characteristics. What would be the characteristic of the image? Number 1, it will be virtual. Number 2, it will be magnified. Number 3, it will be upright. And number 4 will be, it will be behind the mirror. Okay, so I hope you have understood the basic concept of sign convention of the spherical mirror. I look forward to helping you secure full marks in physics, chemistry, maths. Click the link below to join full explanations. Take action today.